earlier, but now they were utilizing only licensed software. And that license may not be available with all the firms or all the colleges, because sometimes the software cost itself might be lakhs of rupees per year. So that way that was a problem. So now again MHRD has now come up with newer set of experiments. They're trying to map up everything. They are trying to change what was created earlier and try to make it completely open source. And that's what I think is the way ahead with this simulation based experiment. And now they're adding some simulation, they're adding animations, and they're providing a complete learning management system. Because many times we always will say, oh, teacher is not good, oh, we don't have good library, oh, I could not come because my bus doesn't work, oh, or something or else. So we always have some reasons that we have, I think, as our obstacles, but can we overcome them? And for that we require a complete learning management system, and that's what this virtual lab is able to provide. But in summary, we should be able to virtualize it. So this is what the concept is, and that's what we have learned from that particular experiment. And why experiments are important. So I think both teachers as well as students will appreciate this, that when a teacher is teaching in a class, student actually tries to, oh, it is very obvious, it is very simple. Because it is being presented in a very logical and a sequential fashion. Because teacher has put so much effort that everything looks very simple and logical. It flows in the classroom. But when the same person, after going through the class, when they go and write the exam, then they realize, oh, things are not straightforward. Though teacher said it so nicely, but probably it is not simple and not so easy as well. Because now they are not able to retain or remember that information. So learning is something different than actually observing. So and observing and or taking it on its face value. And that's where the experiments play a very strong role. Because once a student performs the experiment, they remember the concept for a very long time. The reason is because they connect it to an activity. So only when they do it with their own hands, they remember it as an activity, and that idea gets impressed in their mind. And that, I think, is nothing but learning. Typically, even for the lab, so even in the lab, I think because of limitations of our infrastructure, generally we form a group of 3 people, 4 people, 5 people, 6 people, and they perform one experiment. And in the 6 people or 5 people group, only one person gets a chance to hold the sample, align the sample, put the sample, maybe second person will help them. And now the experiment is complete, and all the 6 people will now make a report. One person may make a report, one will copy a data or what. But apparently the learning has not been imparted to everyone. And even if say assume that each person is given one chance to perform that experiment, the thought of that particular student will be, how do I complete the experiment without damaging anything, and I should get a correct data. And person will be now done with that particular experiment, and that's it. Person was not able to appreciate the results, because what if the sample itself was problematic? What if the instrument was not properly calibrated? Right? So there can be multiple constraints, but the person will not be able to appreciate what has happened or what wrong might have gone during the experiment. So that way they are very, I think, mechanized in terms of conducting the experiment. But that logic is only collection of data, and that's what this green line is showing. So gathering of that information is only collection of data. But now we should get into the second level, which is getting information. So now if I can start connecting the part, if I do the same test 10 times, I also then calibrate the system, I take multiple number of samples, then I will know automatically that, oh, these 2 data points are looking erroneous, because probably the sample was not good, or probably the machine was not calibrated. So now I'm able to say, oh, then I'll take remaining 8, and now I will start connecting them. So that is connection of parts by doing more and more experiments. So now from data set, now I'm getting some relevant information. Learning doesn't end here. Now, another aspect is knowledge. So what will happen if I start making the parameters interact? So earlier I was just doing test on one sample. What will happen if I change the sample size? If I make the sample smaller, what will happen if I make the sample larger? What will happen if I do the test, say tensile test at a different extension rate? What will happen if I change a different set of a load cell? So now that information starts to creep in, and then now it will be kind of interaction between the parameters. Now I'll start to create the whole story. And that's why now from data to information, I'm getting to knowledge. And now the final step is to impart wisdom. So when I get to see all that, now I will reflect on what a parameter is more important, how one aspect might affect the second parameter. Now here I'm in a position to be able to design the experiment. So now from starting when I was doing the experiment, now I have reached where I can design the experiment, and that's the idea of entire learning. And yeah, it takes time. I think it's a time bound activity as well, because as a student we cannot do everything. So it is the responsibility also of the teacher as they grow along to now be able to design the experiment. And I'm saying all is possible through this virtual lab. So in this particular lab, we have developed around 10 experiments, and that says about material response to microstructural, mechanical, thermal, and biological stimuli. As I know most of you are from civil engineering, so what I'll do, I'll pitch it in that fashion, because say materials are everywhere. So you have probably cement and mortar and reinforcing rods and all that. They're also materials. And if to connect it, the inner structure that is called as a microstructure, which our eyes cannot see because it is at a micrometer length scale, has a very strong repercussion on how the material will behave. For me, I may have two buildings, but one building may fail early. That is because of the way you have the reinforcing rods, maybe you have the cement, how they are actually interacting, the quality of it, the composition of it. That is again very, very important. Second aspect is the mechanical and thermal load. So you might still remember this twin tower, catastrophe. So the structure was designed. The twin towers were designed to hold the impact, but it was the whatever that burning fuel, which now started burning, and then that lowered the strength of aluminum frames, because now aluminum had to bear high temperature, and now that it started buckling, and then entire structure actually collapsed. Excuse me. So we need to be able to design something for also accounting for such happenings, catastrophic happenings. So we should also design the material for, say, high temperature, low temperature, impact, and all such things, right? Maybe also vibrations or the earthquakes, what we get. So that way, the design of material is very important, considering the mechanical, thermal, and other aspects of stimuli. And that's what these particular tests have been actually developed. So since the idea is that generally for an experiment, it requires some time, maybe 3 hours. So I think I have very limited time. So what I'll brief you. And the idea is that you go at your own pace, own place, and own time to conduct these experiments. But I will tell you how to conduct them. And that aspect I will highlight during this lecture. Then one more aspect you might be wondering, what is biological stimuli? Why do I worry about biological material? So currently we are actually in collaboration with Curtin University, Civil Engineering Department. They also work with cements and all. Apparently their target is that they should be able to develop anti-fouling materials. So generally you will see that algae, fern, everything especially near the offshore structures, it starts to build up. And that also I think it can also start infecting people, also can enhance the loading that occurs on the system. So can we develop some material which will be antibacterial or antimicrobial? So that aspect can be utilized to develop those materials which are, say, anti-biting or also antibacterial. So accordingly, we have 3 experiments on creep, which talk about material deformation at high temperature. It may look irrelevant, but it is pretty much relevant, because we would like the structure to retain the strength even at high temperatures. And this one again is a first generation experiment. So we had done some simulation, but learning that for simulation, each one may not have the licensed software. So we have captured some screens, and that part we have now shown it to the reader so that they can perform the experiments and grasp something out of this experiment. So creep is plaster deformation, time-dependent plaster deformation at high temperature. Okay, 3 experiments there. Second aspect is assessing the mechanical property. So if you have a composite, and typically that's the case for any material, so we should be able to grab the mechanical properties of individual phases, and that can be done via nanoindentation. So we can go to each domain and then collect the properties. Typically, when we do conventional tests, we take the entire material, we assume it is single material, and then we do the test, and then we get an average property. But if we can know the property of individual phases, then we can also design it. We can engineer it so we can get much better output from the same ingredients. And that advantage nanoindentation can provide. Other component is wetting and fluorescence microscopy. So there so wetting is very important because if I have fern, algae, they require some medium to travel to that particular surface and then get deposited. So like even in cement or once we have reinforcing structure, it is if it actually starts capturing water, then automatically you will see the development of microorganisms in that area, and it may start eating up reinforcing rods, and eventually it will corrode. So if we can make something which is hydrophobic, then it can also start deterring the development or deposition of these microorganisms. So instead of hygroscopic, we want to make it hydrophobic, and that aspect we can see through wettability or wetting. And then how the cells will attack, that part can be seen via fluorescence microscopy. And last one is the ionic conductivity, that is mainly for high temperature energy capturing. But now you can translate it to effective lighting. So if I can develop something which can give me lighting, from natural source by solar or something, even the windows can start becoming darkening and all that. So that aspect can be taken forward for energy materials. So how to use this virtual lab? So this is a link available for this particular lab, material response to microstructural, mechanical, thermal, biological stimuli. So if time permits, I will take you to the lab, but idea is to start with a self-analysis. Because many times students, as a student, I think I know. Because teacher is teaching it in a very logical, sequential fashion. And only when I give the exam, then I get to know where do I stand. That is my baseline. So whenever we start something, we need to ensure that what we have learned is correct. And we also should unlearn. We should unlearn what we have learned incorrectly. That is very, very important part. So for that, we require a self-analysis. So whenever you start an experiment, take the self-analysis first, so you will know where do you stand. After that, go to the aim, objective of that particular experiment, go through introduction, theory, methodology. So that will give you a feel of what the experiment is all about and what is the essence of that particular experiment, what is the underlying theory behind it, and how the experiment has to be performed. Now at this stage, there are some NPTEL lectures which are linked with it. So there will be 1 hour lecture. So please go and see them. You might think it is waste of time, but no, that will enforce your learning. So go and see that NPTEL lecture. That will be typically 15 minutes to 1 hour. But go through them and now come back to your video experimentation. So you might also have some animations. You might have some videos of the experiments, even doing the experiment, also the summary of that video. And typically these videos are very small, maybe from 2 to 6 minutes or so. And so that you can get the entire gist of that experiment in a shorter video. It will contain aim, objective, theory, methodology, also experimentation, and also the outcomes. And that way now you can comprise it everything in a few minutes. Because for teachers, they may not really need to go through everything. For them, it may be a good way to summarize that entire experiment. Now, once you have done that, now come back to experiments, the results of them, and also the analysis. And that is the heart of any experiment, that how you are able to get the results and what are you analyzing out of it. That is the best part of an experiment. Now, once you have done that, now come back to the self-analysis, and that completes the loop. Because you started with something, you went through everything, and at the end now you need to see what you have learned. And to do that, you also need to come back and take the self-analysis test again. And that's how the cycle will get actually completed. So in this particular set, we have 3 experiments on 3 on nanoindentation, 1 on wetting, 2 on fluorescence microscopy, and 1 on ionic conductivity. That is maybe a deterrent, but anyway, so these set of experiments are available. And this is how the website will look like. And you can see on the top, there is something called the self-analysis. And I will take you to the website in a short while. But this is how the experiment will look like. The website will look like. And these are the set of these particular experiment which are probably listed there. So what I can do, I can take you something on wetting. So let me go through this wetting. This is very important, especially for anti-fouling surfaces. So if you can get and appreciate this part. So I'll take you to home first. this is how this website particularly looks like, and you can see this is pretty popular also. Many people I think keep visiting it. But more than that, we now let us go to the experiments. And now out here, say if I click on wetting, it will give me some brief thing about wetting. So it will talk about what wetting is. So it will talk about what wetting is, and then what the system when it is hydrophilic, when the contact angle is less than 90, more than 90, more than 150, that's how the things actually will appear. And now it also shows you some schematic, though they are getting distorted, but nonetheless. And also there are various methods of measuring the contact angle and then how or which parameters affect the wettability. But now if I go back, I will also see a video. I'll come to the video in a short while. But now first thing I would like to do is self-analysis. So self-analysis, I will see these 5 domains. I want to do something on wetting. So let me click on wetting. And this will set the baseline. So I'll just click something on for now. I will select. And once you select, it will remain there. And you can also change the option. So if you think if I don't like this option, I want to go to the second option, then I can keep clicking something, and then at the end, I'll click evaluate. So I have scored 2 on 10. And apparently, it also shows which are correct, which are incorrect. So whatever are incorrect will be shown in the red, and whichever are correct will be shown in the green. So now you'll appreciate, oh, this answer is correct or this answer is incorrect, right? So your focus also will be targeted towards learning of what I learned incorrectly. I thought it was correct, but now it is incorrect, right? So that also will give me a feedback that, oh, this is what I should learn more on. Now going to the experiment. So let me click this wetting. Now this particular, so in this case, so now you can see it's a very short video, only 2.5 minutes, 3 minutes, and it will take you through the journey of, let me go back, about, it will show you what the equipment, how the equipment looks like. It also will highlight the underlying theory. It is something like this. So you can see it in between. What this is, it will take you through all the equations as well. And now you can see how I can measure the contact angle. It will take you through everything, how the wetting is actually occurring. Take you through all the equations. And it will also have some multiple materials. And also it will discuss how things are changing and why. So what the results are. And while showing the results, it also will discuss why the changes are happening the way they are happening. And now they will compare everything as well. So that way now you can learn about the experiment as it is. And these also are very nice and they all are linked. So if I take you back, I am yet to link them, but you will appreciate that. So each particular domain has an NPTEL lecture. So you can see this NPTEL lecture which is now linked to it, and that you can watch whenever you get a chance. So I'll just take one wettability, and now again I'll take that experiment. So it talks about what is the objective, introduction, it talks about methodology, and it shows the results, and also it will compare all what you're getting. So why you should actually expect such a result. So that aspect also will be taken in the conclusion. And that's the end game of any experimentation. Now what I'll do, I'll briefly take you through the other aspects of it, and then I'll stop. Maybe next 10 minutes I will basically stop. So first thing is about creep. Creep is nothing but time dependent plastic deformation at high temperature. So there are 3 different terms. It is time dependent, so with time the performance is changing. Plastic deformation is deforming plastically, and third part is high temperature. So high temperature may mean differently to each. Room temperature is actually high temperature for lead and tin, whereas even 1000 degrees centigrade is a low temperature for tungsten. So we need to also appreciate that part, how the material will change its response when it is being inculcated or being applied to high temperature as well as loading. So here we can see this creep curve has actually 3 stages, but one stage is hidden. That is called as the instantaneous deformation. So as we apply a load, or if we increase the temperature, this inert elastic plus plastic component of the deformation will rise. Then we have primary stage where the strain hardening starts to happen and the creep rate, which is the slope, is decreasing, and the minimum strain rate is in the second stage where the recovery and strain hardening balance. And then later stage when the recovery exceeds, and then it leads to final rupture. And that's how the creep curve actually is. So essentially to restrict any deformation at high temperature, we create obstacles. And that obstacles have to be, I think, allowed in by adding, say, reinforcements of oxide particles, or adding some dispersoids, or even inducing grain boundaries at high temperature. So stable reinforcement at high temperatures. So that way we can restrict the deformation at high temperature. And again, you have an NPTEL link. Nanoindentation, especially utilized for finding the property of each and every phase. Because once we know that, we can always translate them to a bigger picture. So conventionally, we just take an average property from a region. That can be now split into even smaller domains, and now I can get some more information from them. And typically, they're also utilized in nanoelectronics, where I have very small or thin layers, or when I want to see how the interconnects between say 2 electrodes are working, say in a cell phone. So there I may not have enough material, even for biological structures. So these are also very important in assessing those nanomechanical property. And again, you have a NPTEL lecture out here. Wettability, this is what I just covered. So this is talks about hydrophobicity, philicity, and how you can utilize it for even developing, say, windows of a particular building. So how can I make it hydrophobic so water doesn't stick on it and doesn't spoil the visibility through that particular window. So that's where the wetting can be very important. For the offshore structures, it can also provide anti-wetting, and then I can make it anti-fouling surface as well. Or I can also make the cement not so corrosive to the reinforcing rods, which actually bear the entire load of a building. Fluorescence microscopy is again very important part to see those cells. If something is depositing on the reinforcing rods, can I actually see those cells? And that is possible through fluorescence microscopy. So if there's a bacteria or a cell, then we can plan it so we can see the cells appropriately. So that is the part with the fluorescence microscopy. Ideally, cells are transparent to the light. So I need to always put a dye. So I always will color it. Like we do coloring of our clothes, if it is completely white, we will add color so we can get a design. But here I can attach a dye to the different components of the cell, cytoskeleton, nucleus, mitochondria. So I can attach a dye, and whenever I shine light or laser, that molecule gets excited, and now it reflects the light back in a different color. So now for the same reason, once I have a blue filter, I will see where the nuclei is. If I have a green filter, I'll see where the cytoskeleton is. If I have a red color, I'll know where the mitochondria is. Now I have 3 different images. Through image processing, I'll overlap them. Now I will get a single image. And that will show me blue, green, and red color, and that will give a very nice image of the cell as well. So that is what I think fluorescence microscopy is all about. Other is ionic conductivity. So that is mainly utilized for energy application. I will not get into that, but that also is available. So these are the experiments which I will encourage you to take a look at your own time of comfort, place, and own place and time. So in summary, we have provided the explanations for the basic understanding. Videos are also available at all the places. These are very short videos for showing the concept, and experiments are available. But changing the parameters apparently is not so available right now. But in the current format, we are developing some simulation. So in the recent stage 3 of this virtual lab, we are developing where you can also change the parameters. So that is simulation-based experiment. So extraction of result also has to be done by the person, and that is actually in progress. And many are also available for the experiments. Feedback questions are available for self-analysis. And idea is that we also enhance the interaction via some virtual workshops. So like this will also help you to learn something more about virtual labs. So again, these websites are for enhanced interactive learning. Talk to your colleagues regarding the availability of this experiment. Try to map something. If it is not available, come forward and create that content. That is very much required. So experiments from other disciplines also need to be created. and also ask students to be party to it, because many times you think, wow, what, I mean, how can we involve students? But students are very potent in creating this lab because they are the ones who are finally learning it. So they can also contribute, pitch in, also design. So for them, I think it is very easy for them to now get to coding and then be able to design. And support will always be provided by AK2 as well as IT Kanpur. So please come participate. And with this, I will stop here. And thank you, Dr. Chauhan. And in case anyone has any question, I'll be happy to answer. Thank you.
Yes, sir. Yes, sir. Sir, before going, yeah, sir, I'll just take a quick questions from a Shivansh Chaudhary just asking that, sir, I'm not having laptop. Can I access virtual lab on Android phone?
So that was the, I mean, that is the idea, but apparently currently it is not easily working on phones. So we tried that, so it is not working easily. It will require revamping of the websites. But currently, yeah, our eventual goal is that it should reach the cell phone, because currently if I ask who doesn't have a cell phone, I will not find any answer. Each one will have a cell phone. So, but when things had started, it was pretty long back. So idea is to develop something on cell phone, but yeah, currently it is not that, I think, interactive and like this. But ideas, yes, we would like to develop it.
Professor Balani, I have a personal query.
Please.
But I have a personal query that, sir, what will be the next stage of this virtual lab? Is there,
so that's what I was. Yes. So
yes,
okay. So yes. So one thing is, the experiments are part of our curriculum, right? So we are bound to do experiment. Some colleges may not have that infrastructure available. So, but this still they need to do those experiments because that is there in the curriculum. So now, is it really required for each person? Because many of them, I think, they now move towards software, and some people may move to banking, some may write MBA, right? So eventually, I feel that especially at a BTech level, when we are forcing so much on experimentation, maybe 90% or 75% to 90% they move out into these other branches. So is it really needed for them? Probably not. And second aspect is through the virtual lab, now we are at least building up the confidence. So from nothing, when the machine is not available at all, person can at least get a feel by how I can vary the parameters and I can get the output, and then now able to link those parameters, what meaning they bring to that particular experiment. At the same time, there is no danger of damaging that equipment. And I can give any parameters. So yes, like there is a simple experiment of pendulum. From that, I want to know the time constant, depending on the acceleration due to gravity on that planet. If I want to give a string length of 1 kilometer, it's practically not possible. But in experimentation and simulation, I can always give string length of 1 kilometer or 2 kilometer. I can give a mass of 1 ton, which is probably practically not possible. So these things can be always tried. And that actually builds up confidence, because now person can do experimentation. What maximum error message will come? Oh, it is not, it is tracking that particular. So if some experiment is going beyond that range, automatically there'll be error message from that computer that, oh, this is not possible, or you have damaged something. But actually there is nothing. So there's nothing actually getting damaged.
Professor Balani, one more query.
I will just add one more point. And third or more important part also is to map it to the curriculum. And that strategy of mapping it to curriculum has to be taken by us. It means that if we think in our college this experiment is not available, we should create that.
Sure, sir. Mr. Madanji.
Professor Balani.
Yeah, please.
I Madan Chand Maurya, faculty at Civil Department, MMMUT, Gorakhpur, sir. Sir, I have one question. In some experiments at simulation stage or steps, it requires two platforms. One is Adobe Flash Player, and second one is when it is clicked on it requires virtual platform some. So it generates the page of Oracle or some other page. So how it can be overcome, sir? Or
yeah, I just mentioned. Let's see. Apparently, if some labs are developed earlier, we are trying to build them to open source software, but that maybe may not be possible at multiple places. So current experiments which are being developed, they all are on open platform. So they don't require any Flash player, or they are not opening it to Oracle platform. So current generation simulation labs, they all are on open platform.
So Adobe Flash and Oracle both are same, or it will simulate in different ways?
See, I am not able to answer this because this technicality, I am not the right person. It should be an open platform, that's it. If it is being licensed version, then it may not work out. So Oracle, Adobe, I think there is some Adobe what? So that it may not work right now. Yeah.
Professor Balani, I have one more query because there are so many faculty members are also attending this FDP. Could you enlighten us that how they can help in developing their own virtual lab in their university platforms?
That's what I think was the intention. So okay, in that case, we hold multiple number of bootathons. It means that we have a 7-day workshop where one faculty member, 4 students, technical students, and 1 computer science student. So there are totally 5 students and 1 faculty member. They devote time for I think 7 days, and typically these are being held one after the other, and it is very competitive. But there are, say, out of 80 teams, we generally select 60, and by the end there are only say 20 to 30 teams who actually finally are able to complete one experiment. And after this is after exercise of 5 to 7 days. So, but I think a team has to form, and you have to apply for this e-bootathon event, and that's how you can go, and you will get mentorship for everything. Technical content again will have to be taken up by the faculty member, will translate it to the students, and there is one person who knows in and out of at least how to design, how to create a simulator. That help also will be provided by I think IITK as well as this REC Banda. So they are the AKTU Center for Virtual Lab, developing virtual lab experiments. So if you're interested, you can always contact Professor Ashutosh Tiwari in REC Banda.
So we are heading towards developing a virtual lab in our department. So that's why we are just gathering all the information and what resources we would require these things.
Yeah, best is to attend a bootathon, and that will make you complete a few experiments. But I am telling it is highly competitive. And if you apply, it doesn't mean you will get a position there. But there are multiple such events happening one after the other. So maybe if not this one, maybe next one you will get it.
Okay, sir. Okay, sir. Sir, now we don't have any more queries.
I see one more. Just one quick query. I think query has been raised. Deflection of deformation values during creep test. Can you please, Sajad Ahmed, can you please...
Sajad Ahmed, can you elaborate your queries? Sajad?
Okay.
Yes, sir.
So what do you mean by this?
Sir, actually we know that the creep comes with a time, with a particular loading.
Yes. Right?
Hello?
Yes, I'm able to hear you. Tell you.
Just I want to know that what is the deflection of deformation according to that creep?
So that will depend on which application. So for turbine blades, if the creep is happening to the tune of say 150 micrometer itself, that is a failure. So that will now hit the casing, and that entire propeller is gone. Some other cases, if there are boilers and all that, they can sustain up to 2 millimeters. So it depends on which application and how critical that application is. So it's more like if I'm sitting in chair, it breaks, nothing much will happen. But if I'm driving a Formula 1 racing car, if that fails, I will die. So it depends on what criticality of the component you are designing.
Okay, sir. Thank you, sir.
Professor Balani, now we are heading for concluding our session. So before concluding the session, sir, I would appreciate your efforts. In the very lucid manners, you have enlightened us about the virtual lab, because there are so many confusion about the faculties and virtual and students that virtual lab will do kind of a miracle. They are having misinterpretation. So I'm very thankful that you have taken each and every part of the aspect of the virtual lab, what is the behind, what is the purpose, and how it will be helpful for us. So I'm pretty sure that all the students and faculty members are over here. They will be clear with the concept of the virtual lab. And now I thank you again, Professor Balani, that in a very short span of time, with our invitation, you got agreed with us and taking this lecture. Professor Balani, before concluding the session, I'm just handing over the session for your final words for this session.
Thank you, Dr. John. I just want to highlight one point. Don't hesitate in coming forward, forming a team and creating experiment. And I think it may sound, who am I? Do I know that much? But I think don't worry about that. You will have good enough team because faculty member is there to take you through that concept pedagogically as well as technically. Students are there to work hard and then create that particular stream of thoughts. And one technical person can come from computer science department. Now you can really make an experiment. So please, send me an email at least so I can get you in touch with Dhananjay ji or Ashutosh Tiwari ji. And you can also, I think, create an experiment. So don't hesitate in that fashion. So if you need any guidance, we'll tell you. Something is missing, we'll help you. It also gets reviewed. And now not only you, I think entire country, I think globe may be able to access your experiment. So think with that, I think mindset, and I think you can go long.
Okay,
Thank
so
you,
nice
Dr.
of you,
Chauhan.
sir.
Thank you, Dr. Chauhan.
So, sir, I am concluding the session, sir. Thank you for your
Thanks a lot.
time.
And thanks everyone for your patient listening. Thanks a lot.